Hi everyone, and welcome to Geometry Lesson 8.3, Solving Right Triangles. In this lesson, we're going to be looking at how to use the trig ratios to find missing angle measures in triangles. We're going to jump into our first example, and hopefully that'll make things a little more clear. So the first type of example you'll see is one that asks you to use the trigonometric ratio. And here they give you the ratio cosine A equals 0.6 to determine which angle of the triangle is angle A. So what they've done is they've actually used one of these two angles, angle 1 or angle 2, and they've done the trig ratio and they reduced it into a decimal. So either cosine is adjacent over hypotenuse, so 4.8 over 6 is going to be 0.6, or 3.6 over 6 is going to be 0.6. So what we're going to do is use this method to solve. We find the cosine of both angle 1 and angle 2 and divide them to get the decimal, and then decide which one actually does produce 0.6. So take a minute and do that, pause the video, and then hit play to see if you're right. So what I did is I did the cosine of angle 1, which is 3.6 over 6, and that divides to get 0.6. Then cosine of angle 2 is 4.8 over 6, which is 0.8. And then I checked both of these against what I knew I needed, 0.6, and I said, oh, this one is the right answer. So angle 1 is angle A. Okay, so it's your turn to try it. You have a check it out question coming up next. Check it out number 1 asks you to use the given trigonometric ratio to determine which angle of the triangle is angle A. And they've given you two parts to this. Here they said that sine of angle A is 8 over 17. Now notice over here they don't have an 8 or a 17, so you're going to have to actually get a decimal number for this and divide over here to get decimal numbers and see which one's actually equal to this fraction. Okay, now for part B, they said tangent of A is 1.87. So again, you're going to have to divide to see which one divides to 1.87. So go ahead and do that on a paper that you're going to turn in later. So now that we've talked about how to create those ratios, what we're going to do is use the ratios to find missing angle measures. So if I know the ratio of the side lengths, I can find the angle measures using what we call the inverse trig functions. Okay, so if I have the ratio of sides, I can find the angle measures. Anytime I want an angle measure, I'm going to use these functions. So sine inverse, and I would input the opposite side divided by the hypotenuse. Cosine inverse, I would input adjacent divided by hypotenuse. And tangent inverse is opposite over adjacent. And there are special buttons on your calculator to get to these functions. Okay, we used to use these big long tables in the backs of our textbooks, but now we have them programmed right into our calculators. So what you do to get to them is you hit the second button and then you click on sine, and that will get you the sine inverse. If you hit second and cosine, you'll get cosine inverse. And if you hit second and tangent, you would get tangent inverse. So all you would do is you type second and sine, and then you do something like 7 divided by 8. And that would get you the angle measure for which the opposite side is going to be 7 and the hypotenuse is going to be 8. Okay, so it helps you to find those angle measures. Again, you'd want to make sure that your mode is in degrees. We're working in degrees this year, but it probably is since you haven't changed it since last lesson. Let's take a look at an example. Okay, example 2 says to use your calculator to find each angle measure to the nearest degree. So in this one, what you're going to need to do is just type each of these things into your calculator and then just hit enter. So I would type cosine inverse of 0.5 and hit enter, and that would give me that result. Sine inverse of 0.45 and hit enter, and I get that result. And tangent inverse of 3.2 and hit enter and get that result. So try and do that yourself and then see if your answers match. If they don't, please let me know. Sometimes your calculators do strange things, and I usually can figure them out. So just let me know, and we can chat about it and see if we can figure out what the problem is. So I did each of these on my calculator, and you can see the screen shots that I took. Cosine inverse of 0.5 is 60 degrees. Sine inverse of 0.45 is 26.7 degrees, or about 27, because it did say round to the nearest degree. And tangent inverse of 3.2 is 72.6, or approximately 73 degrees. So now you have one to try on a check it out question. Check it out number 2 asks you to use your calculator to find each angle measure to the nearest degree. So in part A, we're going to do tangent inverse of 0.75. Part B is cosine inverse of 0.05 and sine inverse of 0.67. So go ahead and do that after you've paused this video, and then hit play again to see what's next. We can use what we just learned to solve a triangle. Solving a triangle means that you solve for all of the angle measures and all of the side measures. So you find every single measurement for the triangle. So at the end of this, you should have 3 angle measures listed and 3 side lengths listed. Now, I gave you some strategies here. If you're trying to solve for an angle, the first strategy is to use the triangle sum theorem. And we use this if they've given us one of the acute angles, because we know that the other angle in our triangle is going to be right. So in my picture over here, notice they've given me angle Z is 38 degrees. They've given me angle X here is going to be 90 degrees because we have to use right triangles with trigonometry. So here I was able to use the triangle sum theorem. And I just did 180 minus 90 plus 38, and that got me 52 degrees. So I know angle Y is going to be 52 degrees. Now, if they don't give you any angles other than the right angle, because it has to be right in order to use our trig functions, what we can do is use the inverse trig functions. So if they gave us this 12.6 and maybe they gave us zy, I could use cosine inverse to find angle z, because it would be adjacent over hypotenuse. If I wanted angle y, I would do opposite over hypotenuse, because that's what they gave me. It's all about what they give you. Okay, and that'll become more clear on our next few examples. Okay, if they want you to solve for the side lengths, one way you can do it is using the Pythagorean theorem if they give you 2 sides. So if they've given you maybe zx and xy, you can use the Pythagorean theorem to find the hypotenuse. If they give you the hypotenuse on one of the other sides, you can still use the Pythagorean theorem. If they only give you one side, like they did in my picture over there, you're going to make equations with your trig functions. Okay, so notice what I did to find yx, which is this side right here. I did tangent of 38 equals opposite over adjacent. So I got this ratio. And then I solved it just like we did in the last few examples of our previous lesson. I just multiplied by 12.6, and then I typed it into my calculator. Okay, to find zy, I did the cosine of 38 because it's adjacent over hypotenuse. Okay, so I got this fraction, I multiplied by zy and divided by the cosine of 38. And I got this fraction, typed it into my calculator, and I got 15.99. Now, one thing to be careful about is that you don't want to use values that you found, because just in case, maybe I had a moment of craziness and I accidentally got 42 here instead of 52, okay? That way, if I use the 52 on any of these, I'll get wrong answers for these as well. And then I'll have 2 wrong answers instead of just 1, and I'll have more points off. So try to avoid using any of the values that you found when you're trying to find other measurements. Sometimes you can't avoid it, but sometimes you can. So avoid it if you can. Otherwise, just hope for the best. So let's take a look at some examples of this. In example 3, they want us to find the unknown measures in our triangle. They want us to round the side lengths to the nearest hundredth and angle measures to the nearest degree. Notice what they've given us. They've given us two sides. So I'm going to try and find the third side. And if they give us two sides, it's easiest just to use the Pythagorean theorem. So try and use the Pythagorean theorem to find that third side length and hit play to see if you're right. So what I noticed is that AC is the hypotenuse. So I did 7.5 squared plus 5 squared equals AC squared. Okay, I just added these together in my calculator and got 81.25. Then I did a square root to solve for AC. So the square root of 81.25 is 9.01. Okay, and this is the hundredths place, the second number after the decimal, so that's rounded properly. Now we need to find the angle measures, and they haven't told us any of them other than the right angle, so we're going to use the inverse trig functions. And you can choose which angle to do first, A or C, but I would definitely be using the 7.5 and the 5, just in case I typed something wrong into my calculator or something went wrong with finding side AC, I won't be using that measurement. So try and do that and then press play to see if you're right. Okay, I started with angle A. Angle A is here, and I used tangent. Tangent is opposite over adjacent. I had to use tangent because I don't have the hypotenuse measure here, so I only have the side opposite from it and the adjacent. Okay, so tangent of angle A is 5 over 7.5. So what I can do to solve for angle A is use the inverse tangent of 5 over 7.5, and I get approximately 34 degrees. For angle C, which is up here, opposite would be 7.5 and adjacent would be 5. So basically my fraction just flipped. To solve for angle C, I would do the inverse tangent of 7.5 over 5, and that gets me approximately 56 degrees. You have a check it out question coming up next. In check it out number 3, you need to find the unknown measures, round the lengths to the nearest hundredth, and the angle measures to the nearest degree. So notice they've given you F and ED. So you need to find angle D, side DF, and side EF. So press pause, do that on your response paper, and then come back to see the last example. Example 5 says, San Francisco's Lombardo Street is known as one of the crookedest streets in the world. The road's 8 switchbacks were built in the 1920s to make the steep hill passable by cars. If the hill has a percent grade of 84%, what angle does the hill make with a horizontal line? Round to the nearest degree. And I noted here that percent grade is like slope. You change the percentage to a fraction, and that will be rise over run. So that will help you make a triangle. So step 1 here is to actually make a diagram using that percentage. So pause this video, try and make your diagram, and try and figure out which measure they want you to solve for. So I knew that 84% is 84 over 100, and that means that this rises 84 feet for every 100 feet it runs. Now, if I wanted to, I could reduce my fraction, but that's just a lot of extra work. The trig ratios will work perfectly well with 84 and 100. So in my triangle, I made it run 100 feet, and I made it rise 84 feet. Okay, and I labeled the vertices of my triangles as A, B, and C. You didn't really have to label, but I wanted to have something to refer back to. Now they wanted the angle that the hill makes with a horizontal line. Here's the horizontal line. The hypotenuse represents the hill. So they want the measurement of angle A. So we need to solve for angle A. So pause this video, try and do that, and then press play to see if you're right. So I know to find angle A, I have to do opposite over adjacent, and that's tangent. Okay, so tangent of A is 84 over 100. So I have to do the inverse of tangent of 84 over 100, which is 40 degrees. You have a check it out question coming up next. Check it out number 5 says, Baldwin Street in Dunedin, New Zealand is the steepest street in the world. It does not have switchbacks to help with the steepness, which is why it's worse than the street in San Francisco. It has a grade of 38%. To the nearest degree, what angle does Baldwin Street make with a horizontal line? So do that on your response paper and don't forget to submit.